let's go over something known as Gabriel's horn. In order to understand it, you will need to understand a couple of things first. Firstly, you will need to understand what a revolution is in terms of rotating a graph around the x or y axes. You'll need to understand that the volume of revolution around the x-axis is pi times the integral of y squared dx between x equals a and b, and you'll need to understand that the surface area of revolution is equal to 2 pi times the integral of y multiplied by the square root of 1 plus dy by dx whole squared with respect to x between x equals a and x equals b. So, Gabriel's horn focuses on the graph y equals 1 over x. As I'm sure you already know, the graph y equals 1 over x looks like this. But specifically, we're going to look at the graph y equals 1 over x from x equals 1 to infinity. So, more this region. So, more like this, where x is going to infinity. Hopefully I can get it. Yeah. So this here is x equals 1, and then maybe I should have extended the axes, but this here is y equals 1. So with the volume of revolution, when we draw it, it will form a horn, hence the name Gabriel's horn. Let me show it. So it will look something like this. Give me 1 second. So this here is x equals 1. So if you form the revolution, it will form a horn-like shape. So let's work out the volume of revolution between x equals infinity and x equals 1. So the volume of revolution is equal to pi multiplied by the integral of y squared dx between x equals b and x equals a. Y is equal to 1 over x, y squared is equal to 1 over x squared. So it is the integral of pi, it's pi multiplied by the integral of y squared, which is 1 over x squared with respect to x between infinity and 1. And I normally like using limits rather than the infinity symbol directly. So it's the limit of a tending to infinity between a and 1 of pi y squared dx. So pi between a and 1 over x squared dx, which is the limit of a tending to infinity of pi, the integral of x to the minus 2 dx between a and 1, which is the limit of a tending to infinity, pi, and then when you integrate it, you add 1 to the power, divide by the power, so you get minus 1 over x, a 1, which is the limit of a tending to infinity, so pi multiplied by minus 1 over a minus 1 over 1, which is the limit of a tending to infinity pi multiplied by minus 1 over a add 1, which is pi. The reason for this is because as a tends to infinity, 1 over a tends to 0. Now, what we can infer from this is the volume of this horn between 1 and infinity is pi. Let's look at the surface area of revolution. When I'm talking about the surface area, I'm talking about the surface area all the way around. So the surface area of revolution is equal to 2 pi multiplied by the integral of y multiplied by square root of 1 plus dy by dx whole squared with respect to x. So y is equal to 1 over x, which is x to the minus 1. dy by dx is equal to minus x to the minus 2, which is minus 1 over x squared. dy by dx whole squared is equal to 1 over x to the 4. So the surface area of revolution will be equal to 2 pi multiplied by the integral of y, 1 over x, multiplied by square root of 1 plus dy by dx whole squared is 1 over x to the 4 with respect to x between infinity and 1, and I will again use the limit of a tending to infinity, which is the limit of a tending to infinity of 2 pi multiplied by the integral between a and 1 over x square root of 1 plus 1 over x to the 4 dx. So let's consider this integral. Let's label it a. So a is equal to the limit of little a tending to infinity, 2 pi between a and 1 over x square root of 1 plus 1 over x to the 4 dx. On the same axes, I'm going to try and draw the graph y equals 1 over x and y equals 1 over x multiplied by the square root of 1 plus 1 over x to the 4. So let's take some points. So let's take x. So for y equals 1 over x, let's take, let me use the, so let's take x equals 1, 2, 3, 4, and y would just be 1, 0.5, 1 over 3, 0.25. Now, let's consider y equals 1 over x multiplied by the square root of 1 plus 1 over x to the 4. So, if we take the same x values with x equals 1, 2, 3, 4, in fact, let me separate it out. I want to get it to some higher sig figs. So 1, 2, 3, 4. So y will be equal to, for x equals 1, let me just put it into my calculator. So 1 over x multiplied by the square root of 1 add 1 over x to the power 4. So from 1 to 4. So it's 1.41. 4142, I'll do it. And then it's 0.5153, 0.3353, and then 0.2504. So let's draw these two graphs. Let's use red to represent y equals 1 over x and green for y equals 1 over x multiplied by the square root of 1 plus 1 over x to the 4. So for 1 over x, it will look something like this. And for 1 over x multiplied by the square root of 1 plus 1 over x to the 4, what you can notice is, for the same x value, 1 over x multiplied by the square root of 1 plus 1 over x to the 4 is greater than 1 over x. This is because that square root of 1 plus 1 over x to the 4 will always be greater than 1. So for that reason, for any given x value, the y value will be greater for the green line in comparison to the red line. So what does this mean? Well, when we integrate, we find the area underneath the curve. And clearly, the area underneath the curve for the red line between two given points, let's say A and then B here, the area underneath the curve for the red line is less than the area underneath the curve for the green line, because of the fact that 1 over x multiplied by the square root of 1 plus 1 over x to the 4 is greater than 1 over x. So this means that the integral of 1 over x multiplied by the square root of 1 plus 1 over x to the 4 with respect to x between x is b and x is a is greater than the integral between b and a of 1 over x with respect to x. So this means, if we go back to before, let's rewrite it here. A is the limit of a tending to infinity. 2 pi multiplied by the integral between 1 and a, 1 over x square root of 1 plus 1 over x to the 4 dx. A will be greater than the limit of a tending to infinity, 2 pi multiplied by the integral between a and 1 over x dx, which is the limit of a tending to infinity, 2 pi ln a between a and 1, which is limit of a tending to infinity, 2 pi ln a minus ln 1, which is the limit of a tending to infinity, 2 pi ln a, which diverges. This is a known integral. If you integrate 1 over x between infinity and a certain point, it tends to infinity. So this means that a is greater than infinity, pretty much. If you look at the graph y equals 1 over x, this implies that it has this finite volume, pi, but it has an infinite surface area. So if you tried to fill it up with water, you'd only need pi units cubed. But if you tried to paint it, you'd need an infinite amount of paint. And that's why it's considered a bit of a paradox and quite an interesting little problem in maths. Well, thank you for listening, and I hope you learned something from this.